All right, happy Thursday, everybody. What we are doing today is 3D solids using the Pythagorean theorem. So this is basically taking the same shapes that we just did volume with, and now using the Pythagorean theorem with those same shapes. Now, this assignment, there is a total of 16 problems, but I'm going to show you the first three, and this assignment will be due on Friday. So in reality, you're only going to have 13 problems to do over 2 days. So I think you can handle that if you manage your time properly. Do it all today, do it all tomorrow, do a little bit today, a little bit tomorrow. Either way, get it turned in by Friday. Okay, so the instructions say to use the Pythagorean theorem for each problem and solve for the missing side length. Then write an equation to show your work for every problem and round to the nearest tenth. Okay, so if I start with the first one, it says the measure of side C is 150 feet and the measure of side A is 60 feet. What is the measure of side B? All right, so if I look at this, this indeed is a right triangle. All right, so side A is right here, and that is going to be 60 feet. We are looking for side B, which is right here, and then side C is 150. So I could look right at this, and if I write my Pythagorean theorem, I know right away that I know my hypotenuse, which is C. So that's going to be 150 squared. And then B squared is what I'm looking for. And A is 60 feet. All right, so 60 squared is going to be 3,600. And then 150 squared is 22,500. So I simply subtract 3,600 from both sides. So I'm going to have B squared equals, hopefully not at the square root yet, but B squared is going to equal 18,900. And then when I find the square root of both sides, I get 137.5 when I round to the 10th. Okay? So 137.5 when I round to the 10th. All right, so that's going to be the length of side B for number 1. All right, so now if I move on to number 2, I'm going to erase what I did here. All right, and this is part of why I want to go over it with you, is to clarify some terminology. So it says here to find the height of the cone with a radius of 33 and a slant height of 37. So right over here, S is your slant height, okay? And if you look at this, this is a right triangle. So if you look at it from the perspective of being a right triangle, in this problem, you know your hypotenuse, because that slant height equals 37. Okay? And then the radius, which is right here, is 33. So again, we're looking for H. And H is going to be treated like a missing leg. Okay? So we're going to have 33 squared plus H squared equals 37 squared. All right, so 33 squared is 1,089. And then 37 squared is 1,369. All right, so h squared equals 280. Then I find the square root of both sides. And that leaves me 16.7. All right, so that means my missing side there is going to be 16.7. Okay, so that's what you need to keep in mind when they're talking about a slant height. Okay, the slant height is treated like a hypotenuse. All right, so let's move on and we'll do number 3 together, and then that's all for today. And you can go to this on your own and see me on Google Meet if you need additional help. So for number 3, it says the measure of side C. All right, so there's a hypotenuse is going to be 110. And what is the measure of side? And the measure of side A is 45. So what is the measure of side B? Okay. So again, I'm looking for a leg. So I'll say 45 squared plus B squared equals 110 squared. So that's going to give me 45 squared is 2025 plus the B squared equals 12,100. So 12,100 minus 2,025 is going to equal 10,075. And then we'll find the square root of both sides. And that's going to be 100.4. All right, so like I said, you've got the 2 pages to do, but split it up between today and tomorrow. I did the first 3 for you. So go ahead and start with problem number 4, and I will see everybody on Monday since this is due Friday. All right, have a great day and a great weekend if I don't hear from you between now and Friday.